This is video A26. We're now in section 13.3. This is the last section I'll be doing with you guys. Okay, and I'm sure you've discovered by now we're in unit 11. We're not going to finish the unit, but we'll hit the heart of it with this. Okay, and just so you know, when this section is finished, this is such an important section, I'm going to give you these 4 worksheets to do. All of 13.3, all of 4.3. There's one titled 11 Extra Practice, but the big boy, UC1. I would say do that up like 500 times until you have completely mastered this. Come back, watch this video, do it again. Next year, you'll probably begin the year by taking mastery quizzes over something on that worksheet. Okay, so let's go ahead and begin section 13.3. Okay, and we're going to begin by getting rid of degrees. Okay, from here on out in math, we use radians to measure angles. Degrees sometimes. I would say use degrees when the problem references degrees. Otherwise, they're probably giving you angles using radians rather than degrees. Okay, and so let's go ahead and define a radian. So I'm going to draw a circle. I have the center of the circle right here. And I'm going to draw, you guys remember what a sector is? I'm going to draw a very special sector. What I tried to do, here's the radius. This radius is congruent. Okay, and let's call it angle theta right there. And what made this a special sector is what I tried to do is make it so this arc length was equal to a radius. This is not a triangle, so you wouldn't think this is an equilateral triangle. But if you took a piece of string and laid it on the circle right there, stretched it out, it would measure exactly the same as that radius. If that ever happens, then this angle right here is exactly equal to 1 radian. So a radian is the measure of a central angle of a circle that subtends, cuts off an arc with the same length as the radius. Okay, new angle measure. Okay, and so now one thing that would be kind of nice to know is, well, how many degrees is 1 radian? Okay, and so let's think about this now. Okay, so I know that this arc length right here, R, okay, is just part of the length all the way around the circle. And I can make a ratio out of that. The arc length is just part of the whole circle. The measure around the whole circle, the circumference, is just 2 times pi times r. So what I have here is I have part of the circle to the whole circle, and I also know this, in degrees, okay, this angle right here is just part of the whole way around the circle again. Okay, and so the part goes on top just like the part is here. The whole way around in degrees is 360 degrees. Okay, and so now the first thing I see is I can reduce the r's and I just get a 1 there. If I want to solve for theta, I'll multiply by 360. And then I'll reduce the 2 and the 360. And I discover that 1 radian in degrees, because I have the degrees, I should have kept them the whole time, is exactly 180 over pi. So let's see approximately what that is. So 180 divided by, there's pi. It's approximately 57.3 degrees. But since 1 radian is the same as this, I can now use this as a conversion factor. Okay, I can use 180 degrees over pi radians to convert from degrees to radians and backwards. So let's go ahead and practice that. And so let's make this problem 1. And it's convert. Okay, and so let's convert 360 degrees. So since it's in degrees, I want how many radians are in one full circle. This is going to be so important later on, this one little problem right here. So I have to use a conversion factor. My conversion factor is either going to be this or this upside down. And one thing I should note, and I'm not going to explain it right now, the actual definition of a radian is a ratio. And since it's a ratio, it's actually unitless, and we rarely will write radians after our measure, and you'll see as we're going why that is. Okay, so to convert from degrees to radians, I want the degrees to go away, so I'm going to multiply this by pi radians over 180 degrees. And note that the degrees will reduce. So I reduce 360 divided by 180, that's 2. And so the answer, 360 degrees, is the same thing as 2 pi radians, but I'm not going to write radians from now on. Typically, if you see pi in an angle measure, that angle is being measured in radians. Okay, let's do another one. So one thing we know is that if I say here, there's an angle, how big is it? From now on, you're not going to say 360. You're going to say it's 2 pi. Okay, if I say how big is this angle, that's negative 2 pi. So think about that. We're going to do this problem without doing any work. There's a 180 degree angle. How big is that in radians? Well, it's half of the way around. So 180 must be pi radians. That's what this says. 180 degrees is the same thing as pi radians. Okay, let's continue. Let's say I want to know some important ones, like for my special right triangles. 60 degrees, how many radians is that? So I'll multiply by pi over 180, once again, so that the degrees are on the bottom and they reduce. Okay, 60 and 180 reduces to pi over 3. So a 60 degree angle is the same thing as a pi over 3 radian angle. Okay, let's continue. Another important measure. Oh, and think about this. 60 degrees, isn't that a third of the way to 180? So that should be a third of pi, and of course it is. Here, do this one in your head. 45 degrees. For a 45 degree angle right there, well, that's halfway to 90. It's a quarter of the way to 180. That must be pi over 4 radians. Well, let's see. Use the conversion factor. Those reduce. 45 goes into 180 4 times, and we got what we wanted. Okay, let's do the last important one, a 30 degree angle here. Multiply it by pi over 180. You know that's a sixth of 180, right? Because look, that reduces, and you get pi over 6 radians. I hope we're building some just kind of gut understanding now of how big a radian is. Really importantly, guys, know that halfway around a circle is pi radians, and 1 full circle is 2 pi radians. Okay, but now let's go backwards. Let's say I tell you, here's an angle measure. Note I didn't write any units. Okay, it's implied then that that's measured in radians. And if it is, well, I'm going to try to get rid of the radians now and convert this into degrees, so I need to use the conversion factor upside down from how we've been doing it. Okay, and note that the pi will reduce. Typically, you never see pi if your angle is measured in degrees. Look, 6 and 180, 6 goes into 180 30 times, and 5 times 30 is 150 degrees. And then think about that. Just get this gut instinct going. 150 degrees, well, 180 is there, so we're a little shy of that. And we're saying that's equal to 5/6 of the way to pi. And so we're a little shy of pi radians. Okay, let's do one last one. Let's say I have -3 pi radians. You should know the answer without doing any work. How many degrees is that? So let's look. Here's -2 pi radians. There's -3 pi radians. How far did we just rotate there? Well, let's do the work and figure this out. So I'm going to multiply by 180 over pi. The pi's reduce, and 3 times 180 is 540. So I rotated -540 degrees. No, I lied. Let's do one more. Let's do 25 pi radians without using that conversion factor now. Okay, so we would go 2 pi, 4 pi, 6 pi. How many pi's are we going there? We're going 25 pi. Okay, 2 pi would be one rotation. So we're rotating 12 times plus one more halfway around. Okay, and so let's see if that worked. So 12 times 360 plus 180 is 4,500 degrees. Okay, now let's see if that's true if I use my conversion factor, 180 over pi. The pi's reduce, I get 25 times 180, and I get the same answer. So I hope we're building an understanding of what a radian is.